Yalinkiye mutevaako. Kale kenjikutereko. Kale ssebo. Ssebo. Muzeeyi wassu ava kuŋŋamba. Mm. Omusajja omusajja njogeddemukko naye leero, naye kaakole leero then nfune engeri gye mba mikisingamu. Ssebo. Kale ssebo kensooke mmale okukonekitinga musajja wange ono agamba atandike ye leero ku makya. Kale. Mm. Eh, Mhm. Good morning, everyone. Hopefully, everything is nice as of now. Um, for those who have seen um, our communication on the group, today, because of different programs our colleagues are having, we are going to begin with physics. It would have been biology, but we are beginning with physics. Then geography. We are going to welcome Mr. Mugeni on board to take us through some part of geography. I remember Mr. Chagulanyi had completed the section of natural disasters, so they agreed as a department, Mr. Mugeni to come and share with us some new topic also. Then we are going to also have biology last, which was meant to be the very first lesson. So that is the slight change we are having today. In the meantime, we are going to be waiting for Mr. Agaba to come and take us through physics this morning. Then at 10:30, we shall deal with Mr. Mugeni. And lastly, we shall wind up with Mr. Ajojo. Yeah, however, good morning, everyone, and I wish you the best of luck in these lessons you're going to have. And hopefully, whatever will be disseminated will be understood. Um, Let me try to inquire from Mr. Gaba because I've not seen him in our participant list. Uh, And I'm so happy to welcome Mr. Agaba on board currently. Mr. Agaba, please feel free to unmute and talk to us.
Hello. Good morning,
Thank you
everyone.
very much. Good morning, Mr. Agaba.
How are you, Mr. Michael?
I'm okay. How are you too?
I'm doing increasingly well.
Yeah.
Yeah. So I'm also privileged to take part in this engagement of the comrades class, and I'm seeing that the number is a little bit small, but I think we can start. The other colleagues are going to find us along the way.
Yeah, this one is a fair number. We can start off.
Mm.
Mm.
Okay. Thank you. I shared the work with Mr. Michael. I do not know whether he shared it with you or not. If he didn't, then I think he will. He will. Let me just send him a text to forward that work because I just sent him a mail. If not, I'm going to, let me see. Let me add my email on this platform here so that when we finish, I will share the work to one of you so that it can just come to you direct. Can be a little bit easier as I share the work. Yeah. I think that is the one. Yeah. Just send a text there. I'm going to just forward, but I shared the work with Mr. Michael. So allow me to take this singular opportunity to start today's presentation, and we see what we can do. Okay. Hopefully you can see my what? Can see my screen. Now, yesterday we discussed about the arrangement of the lighting systems, the pair arrangement, series arrangement, which one is more preferred, and what not. Now, we must know that electrical components which are under usage, they consume some electricity, and that electricity is paid for. And today, we are going to see we can compute that cost of what? Electricity. Now, in the early days, people used to have those domestic meters, which you would first use and after you pay. But nowadays, there are these meters whereby you first pay and then you use. The other ones were prepaid. You would first use, but now here, the others you would first use and then pay later. But now these digital meters, you first pay, then you do what? You use. If you buy your 10 units when they are done, automatically you go off. Unlike in the early days, where you would first use, sometimes they would come to demand you even take a height as you look for the money. Or sometimes they would manually disconnect you, but now it is a system. You can't say that now, you know what? I didn't pay, but let me just keep lighting. I'm going to pay when I get the money. Does not work. If you buy your 2 units when they are done, automatically go what? Go off. You have looked at those domestic what? Domestic meters. But the idea behind them is that all of them are going to measure power, and under cost of electricity, our power is measured in kilowatts. Because in the previous discussion, we said that power is I what? IV. Current times what? Voltage. And the unit is watts. So for us to get the number of units used in a given day, you must get the power in kilowatts, then multiply by the time of using a given device in hours. What does it mean? When power has been given in watts, convert to kilowatts. When time has been given in any other units which is not hours, convert into hours, just as you are going to see. And here we are saying that a kilowatt hour is just the amount of electrical energy consumed by a device of power 1000 watts in 1 hour. That's what we mean. That 1 kilowatt is equal to, it is 1 kilowatt times 1 hour. 1 kilowatt means just simply 1000 watts, because a kilo means 1000. 1 hour has 3600 seconds. 60 times what? 60. That one we can get, which means 1 kilowatt is equivalent to 3.6 million joules. Because when you get this 1000 multiplied by this, should be getting this value here. But that is not a big what? A big deal. Now, the big deal is for us to get the cost of electricity, we get power in kilowatts times time in hours times unit what? Unit cost. In most cases, we shall give you power either in watts or in kilowatts, but the idea is it must be in kilowatts for you to compute. Then time, we can give you minutes, we can give you days, but you must convert into hours. Then you multiply by the unit what? The unit cost. When you know that, now that physics is going to be growing. Will be growing. That's what I do. What I mean. I think I should have put. Let me see. Maybe examples like that. Now, here, this question is, how much will it cost to run for what? For bulbs. Each is rated what? Power is 40 watts for 2 what? For 2 days. If each unit of electricity costs what? Costs 30 shillings. So what do we need? We need power. Let me say, here we have 2 bulbs. We shall look for total what? Total power. So this total power is going to be, there are 4 bulbs, each rated what? So it will be, if you have 4 bulbs, each is rated 40, it means to get the total power, you are going to get 4 times the rating of each what? Each bulb. 4 times 40. And I think this answer is what? This should be around 160 watts. But what have we said? We are saying that this power must be in kilowatts. It is here That the cost is given by power in kilowatts times time in hours times into what? Into cost. What do you do? Convert to kilowatts. So what do? I get this one simply means get 160 divide by what? Divide by, let me get this. Divide. To be 160 watts out of one what? 1,000. Because you said that a kilo means what? Means 1,000. And I don't know if there is any of you is getting the answer. Let me check. Get for me that answer there in kilowatts. Get for me that answer in kilowatt. In kilowatts. What is that? I'm getting, I should be getting, I think it should be 0.16 kilowatts. I think it should be like that. That's what it should be, 0.16, yes. Now time equals to what? 2 days. Maybe this could be maybe security lights, and maybe you have moved away for some time that they have been lighting fully. So these 2 days, each day has 24 hours. So it will be 24 times 2, which I think this gives us what? Around 48 what? I think 48 what? Hours. Unit cost. How much does each kilowatt cost? It is 30. 30 what? It is here in the question. So we said that the cost of electricity equals power. This power must be in kilowatts times the time, and this time must be in hours times the unit what? Unit cost. So this will be power is 0.16 times time, which is 48 times 30. Somebody get for me that answer there. Because for me, I don't have a calculator. I want the answer from you. Then I put it here. We conclude. This one is saying me. It is what? I know that this is the one. Somebody to confirm. I'm just getting it from your side. So this one is telling me to. Like that. That is what? Good. Good. That is what we are saying. For this what? For this case. That's how you can what? You can think about that question in that given what? Given order. So it means that whenever you are given such a question, what do you need to understand? You need to understand this, that power is given by that, then do the substitution, get the what? Get the answer. The key idea is this, you need to take kin of the units. And after that, we conclude. Therefore, it will cost shillings 230.4 to run the bulbs. Then you go what? You go away. I think that is okay. I don't know if there is a question there. Then question two. What am I saying here? That what? Find the cost of running two bulbs, rated that. Aha. So here, let me see. Find the cost of running to run two bulbs. Bulbs are two. Then an electric flat what? For that 5 minutes. So what shall we do? We shall look for total what? Total power. This will be equal to bulbs are two. Each one is rated 60. This is for bulbs. So it is 2 times 60. But a flat iron, I think it is 1. So I add the one of the flat what? Flat iron. Somebody get for me the answer. 120 plus 120. I think the answer is what? It will be 240 what? 240 watts. That should be 2. Oh, sorry. What is this? This should be 2 what? 240 because that is the one what? Then convert this in kilowatts. You say in kilowatts. You just divide 240 divided by 1,000. I think the answer is 0.24 kilowatts. Check if it is the one, and you confirm with me there. Even though it may not be the one. Then time is there. All that we need to convert time into what? Into hours. Time equals 35 what? 35 minutes. To convert into hours, we divide by 60 because each hour has how many minutes? 60 minutes. So this will be equal to divide by 6 and get for me the answer. Let me see. This is okay. Let me see. This is, I want to say 35 out of 60. Divide. And the answer is what? Do you round off or you don't round off? I used to have a calculator. I don't know. If it gives us a decimal, we can first maintain. Let me check also. 35 divided by 60. Divided by 60. Oh, let's maintain that fraction so that we don't work with an error. These are hours now. Yes. Then unit cost is there. So I'm going to let me get my what? My formula here. Cost of electricity equals that. Equals this. Power in kilowatts. We already have it as 0.24. Time in hours. Let me get this here. Time in hours, I will be having, I think, 35 by 60. Yes. multiply by unit cost, unit cost, unit cost. It is here 415 times 415. Yes, somebody get for me the answer there. Want the answer, 35 divided by 60, yes, times 0.24 times 415. I'm getting around what? 58 point, probably 1.1. I don't know if that is what you're also getting. Good, good. It means we are what together. And after that, we conclude. We say therefore it will cost 58.1 shillings to run those devices. So that is how those guys of Umeme come and they do what? They bill you using that what? Using that system. And there is this question, what? Question 3. An electrical heater is rated what? Is rated 3,000 watts and 240 watt, 240 volts. The first statement is, what does it mean by this statement? And I think someone shall ask for power. So let me first copy this briefly. Briefly. Bring it here as part of what? Part of the solution. This is what. Now, we said that power, to give you a hint, power, we said it is I what? IV. And power is measured in what? In watts. And in fact, I made some statement somewhere. Yeah, yes. That 1 kilowatt hour is equal to, it means a kilowatt hour. Or in fact, a watt hour is the same as a what? Is the same as a joule. When you look at this other statement. A kilowatt hour is the same as a what? The same as, or a watt hour is the same as a joule. Because energy is measured in what? In joules. Now, we are saying that if in this case, somebody can say that this heater consumes power of 3,000 watts when it is connected to a 240 volt supply, or somebody can convert this power into what? Because I said that a kilowatt hour is the same as what? A joule per what? Per second, which means that, remember, power is the rate of transfer of electrical energy. We discussed that the other what? The other time. And energy is measured in what? Can say that power is the rate of transfer of electrical energy. Rate of transfer of electrical energy. And this means energy divided by time, which means energy is measured in joules and time is measured in what? in seconds. That's why we are saying that that this statement just means that this heater consumes 30 joules of, let me add it there, of electrical what? Of electrical energy every second when connected to a 240 mains supply. That's what we need to have. Okay. Then question two, Roman what? Roman 1. I think we are here, we are going to, in fact, we are going to use now this. We're going to use this. Power is I what? IV. Power is I. Oh, there should be B somewhere here. Power is I what? IV. Power is IV. Power, let me see. From the question, power is 3,000 watts. Voltage equals 240 volts. So we can substitute in and we see. So power will be equal to, no, I want what? I want current. For current, I'm going to use the same statement. I substitute in. Power is 3,000 is equal to current, the one we want, times the voltage, which is 2 what? 240. So to get I, we shall divide. Get for me that answer there. 3,000 by 240. That will be the answer. Three thousand by 2 what? By 240. 3,000 by 2. So and it's telling me that the answer is 12 point what? 5. Good. So the current, current equals 12.5 amperes. 12.5. Because here, just as you can see from your mathematics, at this level you divide throughout. Becomes easier. Becomes so then we know that from Ohm's law, let me say for resistance, you discussed that let me see, is there a constant here? 12. Oh, sorry. There is a problem. Yeah, like that. For resistance, we shall use Ohm's what? Ohm's law. And Ohm's law, you discussed that that the law states that current flowing through a homogeneous conductor is directly proportional to the to the ED across its ends, provided that the temperature and other physical conditions are held constant. And you discussed that by summary, Ohm's law is this. V equals I what? IR. We have V, we have I, we can get R. Our V is here 240. We have got our I as 12 point what? 5. Then we want resistance, R. Yes. So somebody get for me the value of R after dividing throughout. Divide, and get for me that answer to become good. Let me check if there is so it will be 240 by 12 point what? By 12.5. 240 by 12 point what? 0.5. Answer is what? 19.2. Good. R equals 19.2. Oh, here. R equals 19.2. I go to the symbol for an ohm somewhere. It is here. Yeah, ohms. Hopefully that is the SI unit. And the question wanted the current and resistance. You say therefore, conclude. Therefore, the current of the heater is 12 point is what? 12 point what? 0.5, I think amperes, and the resistance is what? 19.2. 19.2 what? Ohms. I think that is what? That is okay. That is what? Okay. That is okay. Let me check if let me get this also. A good question now. No. Let me first cut this. I've just paused a little to get this book. Is this? Now, after this, I can get for you a very good question of electricity. Let me get it. Let me get it. Is this very good and huge? Let me first organize it and put it what? There for what? For practice. For practice. The task is there. And we are going to work. I want like 2 questions. Two. Let me pick another one. The one which has the table now. Get it. Yes, yes. I think this was a label question for 2025. Yeah. So the label question for 2020 what? For 2025. I'm going to pick out some parts which we can manage. Good. Let me bring it what? Bring it here. I think I'm going to start with this enable question. Hopefully you can see. Very what? Very well. But before that, let me see. Let me put here some tasks. Then we discuss it briefly. Then we got those two questions. I want us to look for ways of minimizing stroke, reducing the cost of electricity. What should we do to save power? I want us to take like 4 minutes on this, and then we can continue with our calculation. If you are the mother or the dad, or what will you do at your home, or which rules will you put at your home so that the bills of electricity don't become so what? So huge. I want to type those answers here. Let me check if there is one. Turn off bulbs when not in use. Good. This one has given us one. Is you're going to say not only bulbs switch off, switching off all idle. They can be bulbs, e.g. bulbs. It can be a television. It can be maybe which other one? Even the flat iron, what? etc. Let me get another one here. Use of energy saving what? True. Use of energy saving bulbs. And these bulbs are normally what? LED. Good. Which other one? The notes I will send. Television, already have that. Please give me those answers, those rules you put at your home. Oma will say, minimizing, let me add this, minimizing the use of high energy consuming devices, e.g. flat what? Flat iron. What we do here, you are advised like it always iron at what? At once. You should not maybe use those devices every time. Can be a flat iron, can be a percolator, water, can be a water heater, etc. You just minimize. Which other method can we use? Let me check here what this person say. Avoid charging what? Charging batteries. Charging batteries. Phone batteries. Oh, because I think to be one of the ways of you are minimizing. Maybe what you can say, if you have, suppose that maybe you have what? Charging a phone. There you are going to I'm going to say, let me put this point. reducing, let me say, reducing on the time, reducing on the time of usage of what? Of devices. If you are going to charge, maybe charge once a day. If you are going to watch, do not, if maybe you have a maid at home, do not let them start watching in the morning up to late in the evening. Maybe you can say maybe start maybe watching maybe in the afternoon like that. Hereby you are reducing on the time of what? Single devices, e.g. what? E.g. A television. There it will be what? It will be good. Good. Which other method can we employ? When not in use, I think that is switching off idle what? Idle appliances. That's what we mean. It is included. Which other one? Which other one can we? Then we can also adapt use of alternative sources of what? Alternative sources of energy. E.g. solar. Solar what? Energy. You can decide now to maybe use some solar energy for your lighting purposes. You can also use biogas to do the cooking, like that, instead of largely depending on what? Depending on electricity. Because of largely depending on electricity. Other alternatives, this one has it good. Avoid charging using naked wires. That one is correct, but not right. Because that one will just help to prevent electric shock, but will not reduce the cost of what? Electricity. Which other method? Which other method? Which other method? Let me see if there is any. Please add it. Let me see if I can get. I think we have almost exhausted all. So I'm getting one here which says what? Unplug. And what? Oh. Unplug. Unplug. Appliances when not in what? In use. Yeah, some of you do maybe there you are charging. After charging, your friend calls you. You just pick the phone from the charger, you go communicate, maybe you don't put it back. So what do? We are advising that now, if you are no longer going to charge, just unplug the charger, because it will still keep consuming somewhat, some power, though it will be small. So please unplug. And any other device, no, and any other method you can add. There is this practice item. Practice what? Item. It is where? It is here. It is here. I think it should be, what should I do? Bring it what? Yeah. This will be a good one for you. So what are we saying? That one is okay. Avoid putting many devices. Yeah, you can. That's why we said you can add there, reducing on the number of what? Used what? Devices. Not use a flat iron. Use a, a don't use a flat iron, a heater, a cooker, a television, just in a single day. You can decide to be using one at a what? One at a time, so that you can save the cost. Now there is a good question here. We want to see how we can attack it. Yeah, I think we can see. This question says, let me check. I'm going to unmute one of you so that he reads it. We start answering it. Who is this one? Somebody who's ready to read, you can raise up the arm. I unmute you. You read the question. We start answering it. Who is this? Nisima, you can unmute.
Yes, teacher.
And you read. Read the question.
A parent had a small piece of land beside his main house. He decided to put up a two-roomed rental for purpose of increasing on his average income. He, however, set the rentals directly below electric transmission power lines and installed one electric meter to be used by two different occupants of his rentals. Misunderstandings arose as it was not clear which occupant to pay how much of each electric bills. It was, however, discovered that the two occupants used one inside bulb, each of different rating, and one common security bulb. It was further discovered that occupant of room number 1 was using a flat iron rated 1000 watts for 30 minutes per day, TV rated 150 watts for 4 hours per day, and a light bulb rated 7 watts for 5 hours per day. Occupant of room number 2 was using a kettle rated 1500 watts for 40 minutes per day, and a light bulb rated 10 watts for 5 hours per day. The security light is rated 10 watts for 5 hours per day. Hint, cost of 1 unit in brackets 1
kilowatt hour.
1 kilowatt hour is equals to Ugandan shillings 504. Task, prepare a sensitization message to this parent in brackets landlord and the community why they should not build under electric power lines over long distances. B, help the two different occupants each to understand how much of the total bill is supposed to pay in 30 days. C, as a physics student, advise the occupants on how they can save on the consumption of power.
Good. So, is one of the questions you may expect. Is one of the questions you may expect as you go You go on. Now, let me first start with what is known. The other one, you're going to see. We want to find out which of how much is each of them supposed to what? To pay. In how many days? In 30 days. Now, what are the devices being used? Let me say, I think I can even have what? Do this, say this, yeah, like that. I say occupant in a room 1, occupant in a room what? In a room 2, right? Yes. So occupant in room 1, it was discovered that the two occupants used one what? Inside bulb each of different what? Ratings with one common what? With one common security what? Security bulb. So that information is important. Then occupant room number 1 had a flat iron. Flat what? Flat ion of rating. Let me see. Flat ion whose power is 1000 watts. Time of usage 30 minutes. 30 minutes. Then you also had a TV. Whose rating is what? TV is here 150. 150. Oh, sorry. Is here 150 watts for how many hours? 4 hours per day. 4 hours. What else was he having? A light bulb. Bulb of how many watts? 7, okay. 7 watts. For how many days? For 5 hours. 5 hours. And now we shall also need security what? Security light. Now security, let me say bulb is rated what? This per day. However, they said that this is shared. You get it? Because it was they were sharing a security what? Light. The statement was somewhere using that. Yeah. And one common security what? Bulb, which means for the security bulb, now this man, the occupant of room number 1, should pay half of that what power, which should be, this is the security is rated 10 watts, which means the other one is going to pay 5. The other also pays for 5, because they are how many? They are 2. You get it? For how many hours? 5 hours per what? Per day. So in order to determine how much each person should what? Should pay. Then for number, let me see if there is a concern here. Okay. For number what? For this room 2, this person has room number 2 has a kettle. Let me bring this information here the way it is. Bring it. Kettle for 40 minutes per day. Then light per day. Then security what? Bulb. So this security bulb, this guy is also going to take what? Just going to take 5. 5 what? 5 hours. So what do? We say, what is the total power here? Total power. Let me say total daily power used will be equal to now here what we do will be this person here who is playing with the screen. I don't know whether the person is who, but if you have those fingers which are moving like that, stop. We are going to look for cost. We said that cost is by formula here. I think I should have, did I finish this question by the way? I didn't, but here you'll finish. Yeah, you finish this other part. I said that cost is given by this. So we are going to work here. That is the formula. So I'm going to do one by one. So here, let me say, this will be 1,000 divided by 1,000. This is 2. No, not even 2. This is 1 kilowatt. Here, when I convert here, divide by 1,000. Then here, divide by 1,000, what do we get? I think it will be 0.15 kilowatts here at this what? At that level. Then this is divided by, I think this should be 0.007. Yeah, kilowatts. I'm also getting it. Then this will be 0.005 kilowatts when divided by 1,000 in order to convert that power into what? Into kilowatts. So this will be what? That will be that. For how many days? 5 hours per day. Okay. These were 5 what? Hours. So what does it mean? This one is when you divide this by 60 to convert it into hours, this becomes what? I think 0.5 hours. Is it? Check so that we can compute. So for the flat iron, power is going to be 1 kilowatt times time in hours, which is 0. Time in hours is what for the flat iron? 0.5 hours times unit cost is 504. This is for the flat what? Flat iron. Add the one of the TV, which is 0.15. The TV is used for how many hours? 4 times what? 404. Yes. Add the one of the bulb, which is 0.007. That bulb is used for how many hours? 5 times 504. Then add the one of the security bulb, which is 0.005 times how many hours? 5 times 50 what? 04. Get the daily what? Daily cost. Daily cost. I don't know what you get there, but the computer can get for me the answer there. Then I write it here so that we can what? Can move quickly. I'm waiting for that. Yeah, time has run out, but let me just conclude this just like 2 minutes. So you'll do the same for this side. You'll do the same for this side and see which of them should pay how what, how much. I don't know what is the total. Is somebody computing or you are chilling as this Shasha is saying? You need to compute here so that you can what? Can get it. Get it. Then lastly here, we shall need that. Then I can also bring this. This one will be very quick. Very quick. For the bulb, this one will be 1.5 kilowatts. The bulb is used for 40 minutes. 40 divided by, let me see, 40 divided by 60 is what? 40 divided by 60 is 0 0.66 7 and say first 10 1 10 in kilowatt 0 times the 5 hours. Then for the security light, it will be 0.05 times the remains. That's the need to have in our what? Our work. The answer you get, you compare them. Because for my what? Calculator here, I don't know what is the answer. This one. Even for that, I can just conclude for that question. Total answer seems to be this. I think it is right. Because for I'm not working. Get for me the one over here. So that we can conclude at what? At once. For your work, you will share with me. You will share with somebody will send me a mail on that email address I have put. And I just drop. To be a little bit. Be a little bit what? Easier. Let me check. Has anyone obtained the answer or because time has run what? It's run out. That value is it correct? How many points are these ones? It is not. You check your answer. It is not. This value here. 87 point and another point here. Check your computation and see. Yes, that could maybe it could be okay. I see we're getting different answers. Now which one is the right one? Somebody else to confirm the one who is computing so that we can end. Is it? If at all. Maybe it is the one. Let me get it here. Like do what? Put it. Good. So you can see this one has that. So it means that you conclude and say this one is supposed to pay. Say. I'm going to say, as I end, therefore, occupant in room number 1 has to pay 586.44, while occupant in room number 2 has to pay 542.025. Good. That is it. That is it. That is it for today. This one, you'll practice it. You practice it. I think you can even manage it by the apart from a few things here. Yeah. That is it. Have a good time and a good morning. And the best of the rest of the day. Bye-bye. I don't know if there is a question by there before I just sign out. This one is saying that the first... Anyway, it is okay to make additions in your work. I believe everybody had a calculator. Just send a text. Let me repeat the email here before I just leave. Just send it immediately. Because I'm just going to make a PDF now. I share with one of you, then you will what? You will be receiving it. That is the one for today and what? And yesterday. Have a good time.
Thank you very much, Mr. Gaba, for the presentation. Up next is going to be geography. Let's have a break and wait for Mr. Mugeni. We shall be open 5 minutes to 10:30 so that we are ready for geography. Thank you very much for attending. Let us go for a break.